Okay, we have this question about attendance and punctuality. 50% won the award, which is this is a weird sentence. First off, we'll talk about what this means in a minute. 40% have attendance and 20% have punctuality. One of the best ways to tackle a problem like this is using a Venn diagram. So we're going to put attendance here. I don't like that color. Let's change it to red. We'll put attendance here. Let's do this a little bit bigger as well. We'll do A for attendance and P for punctuality. Sound good? Now, your first instinct, a lot of people's first instinct when filling out this Venn diagram is, okay, well, they told us 40% of people got the award for attendance. So a lot of people want to put 40 right here. You see an issue with that? Maybe you didn't.
There's some of that 40% included in the middle.
Exactly. There's something supposed to be here. You can't just lump all of that 40% into this section over here. So that's going to cause an issue if you decide to call this 40. In the same fashion, I can't call this 20%. We were told that 20% of people have punctuality or won the award for punctuality. But again, you can't lump all that 20% in this section because, as you said, there's some of that stuff is in the middle. So how do we figure out how much is here? Here's what we're going to do. In a situation like this, we're going to call that. Sometimes they tell us right off the bat. Sometimes they say, 10% won for both attendance and punctuality, right? Unfortunately, we don't have that. And in fact, that's the very thing we're being asked, right? The question wants us to find the probability they have both attendance and punctuality, right? Isn't that what the question is asking?
Yeah.
So we don't know this value in the middle. For now, we're going to call it X. Does that make sense?
Mm-hmm.
There's a couple things you can do. A lot of people might be tempted to multiply these probabilities. So you could multiply the probability of attendance times the probability of punctuality to get the probability of the intersection. Only if they satisfy a certain property. You know what that property is?
Is it the independence?
Yes, correct.
One.
Right.
Okay.
So, but only if you're told they're independent. Were you told anywhere in this problem they were independent?
No.
No. So multiplying these two individual probabilities, multiplying these two probabilities here will not do the trick. So we're gonna have to try something else. The alternative route, as I've begun describing, is just calling this middle part X, because we don't know what it is. Is that good so far?
Yep.
With that in mind, that means the remaining part of this will be the 40% minus X, and this will be 20 minus X. After all, these two things, let's do the drawing tool again. These two things need to add up to 40, and these two things need to add up to 20. Here's where the last sentence comes. Here's where not last sentence, I guess it's the first sentence. The one thing we haven't used yet is what I mean by the last sentence. It says that 50% won the award. What does that mean? That means these were people who were either in this camp, or this camp. Because you win the award so long as you were either have a record for attendance or you're punctual, or both. So what we're saying here is that these numbers together, all three of these numbers add up to be how much?
50%.
Exactly. Yeah, exactly, 50%. So let's go ahead and do that. What we'll do is we'll hit the undo button so that we get rid of that bubble. We will take the 40% minus X plus the X plus the 20 minus X. I'm basically taking all three of these numbers and adding them up and setting this equal to 50 to solve for X. So I get 60 minus X plus X minus X. We notice that a couple of those X's will cancel, right? Plus X minus X will just cancel. And I'll get 50 here. Solving for X, I just get X equals 10. And it always helps to plug these back in to make sure everything checks out just fine. So if we do indeed get X equals 10, we put that there, we get 10 here, and we get 30 here. Does everything check out? What is the sum of the values here? 40. That checks off the attendance part. And the sum of the values here is 20. So that checks off the punctuality value as well. I mean, in a situation where you're pressed for time and you wouldn't know how to, let's say you didn't know how to do this, you could probably start guessing at values of X. You can say, okay, well, I need to make sure that whatever value of X I pick that goes in here, and therefore in here and here, needs to be such that once I plug it in, these two sum up to 40, and these two sum up to 20. So let's say you didn't know the algebra, you could at least start trying to guess values of x and then make sure that the values add up to what they need to be. Is that all good?
Right.
Any
So
questions? Yeah, go ahead.
this is a non-independent joint probability.
Correct. This is a question where they did not tell you they were independent, and so we were kind of left out to dry. We had to try something else. In that situation, we opted to call the middle piece x, and then we started figuring out that this had to be 40 minus x, given that we know this is 40% in the entire bubble. And in a similar fashion, this is the right-hand bubble needs to be 20% punctuality. So if x has been used up here, that means there's 20 minus x left in this category. The weird part here about this problem is this sentence here. The 50% won the award. What does that mean? Well, it means that they were either had good attendance or they had good punctuality or both. It just tells you that winning the award means you are somewhere in one of these circles, one of these bubbles. And then there are people who didn't win, right? They could have followed up and asked something like, my Zoom text bar. They could have said something like, what's the probability that somebody had perfect attendance but wasn't punctual? And so you would just go look at the category that satisfies that criteria. Having perfect attendance but not being punctual is this 30% over here.
Okay.
Cool. All right. I'm going to stop the recording there, and thanks so much.